Okay, so what did we discuss last time? Do you remember? I'm just wondering why we couldn't finish these branches. Okay, that's fine. I was just kidding. I know what it is. So, yeah, but it looks like I jumped over a few things last time. So I'm going to discuss some. So last time we talked about MATLAB operators, and also, in addition to normal operators that you have in your calculators, like plus, minus, division, you have additional operators that are preceded with dot. And I told you what the meaning of dot is. Remember? What does it mean? Yeah, you don't need to remember anything from the previous lecture. It's just there, right? So it says element-wise multiplication, which means that you multiply the elements one by one with each other. The first element with the first element, second element with the second element, and so is the element-wise division. And left division. What do you know what the meaning of this left division is? Okay, great. So the normal division, the right division, divides this number by this number. But the left division does it in the reverse order. I don't see why one would need such an operator, but anyway, MATLAB has it.
Because they can.
Because the what?
Because they can.
They can, yeah, exactly. That's the reason. They just want to be as comprehensive as possible. Just try to create any function, any functionality that you could imagine for you, so that you don't switch to any other thing like Maple or Mathematica or something else, I guess, maybe. So, but I didn't tell you about these logical operators. We discussed them a little bit at the end of the class. The AND operator, or, and bitwise, or short circuit, and short circuit, or, and also not at the end. So how many of you know about logic and logical operators already? Okay, cool. So when I say AND, how many of you know what AND means? If I say A and B, both of them should be correct in order to get a correct answer. So if I say, email me if you haven't been in this class and you haven't done your homework, what does it mean? It means you should, both of those two statements should be correct in order for you to email me, right? Or when I say, email me when you haven't done your homework, or you haven't attended this lecture, or you haven't attended this lecture, that means either of these two. If either of these two is correct, just email me, right? So that's the meaning of AND or. And then how about short circuit? What do you think it means? Yes?
It just divides the first half of the sign, and if that satisfies whether the whole thing's an integer or not, it doesn't even look at the right side.
Right, exactly. So let me show you what it means really. So I posted your grade quizzes, the grade distributions, by the way, and I emailed you all that. So let's see. Let's say true and false. It wouldn't. No, we cannot see it. So basically what happens is that if you have two statements, let's say, not true. Yeah, true is fine. So if I have true or false, with short circuit, as soon as you reach this operator, and this is true, you don't need to calculate the rest of this logical statement, right? Do you see why? Can somebody explain why with short circuit you don't need to calculate the rest of the statement? You don't need it because you know already the result. Yeah, because this says if this is true or this is true, then do something for me, right? So as soon as you reach this or short circuit or, you don't need the rest because you already know this statement is going to be evaluated as true in the end because of this or operator here, right?
Not to just use short circuit all the time.
Yes, there's a good reason. What's the reason, do you think? If I don't need to calculate the rest of a statement. Time, faster, yes. Very good. So in other languages, this might not be explicit. So you don't have a notation for it, but most compilers so they have their own rules. So it might not be a part of the syntax or the standard of the language itself, but the compilers, like for example Fortran compilers, different Fortran compilers have different rules for short circuiting. Some of them do short circuiting, some of them don't do, so you have to be careful with this. But with MATLAB, you're safe. As soon as you use short circuit notation, you're going to be fine. When I learned about short circuiting first time, I thought something like this. Yeah, so that was really my impression of short circuit, but this is something beyond that. So let's see what MATLAB has. Short circuit, yeah. So you can see more information on MATLAB manual. As I said, always the best reference is the MATLAB manual. But before that, I think I didn't tell you also about implicit type conversion. I don't know how I could skip this part, which is like a few pages. But about MATLAB type, so I told you already about different types of variables that exist in MATLAB. All these different types, numeric, cell, and all of them. But here's the thing. In MATLAB, you can convert any variable at any time to another variable type. You cannot do this, for example, in C or C++ or Fortran, those compiled languages. You have to define your variables first, and you cannot change their definitions later on, their type, later on in the code, right? I mean, you can do it in some really crazy ways, but normally you're not supposed to do this, right? So because of this, these languages, the compiled languages, are called a strongly typed language, meaning that you cannot change the type of a variable later on in the code. But MATLAB is not like that, so it's called weakly or loosely typed language. And if you click on it, I don't know what it gives you, but it takes you to the Wikipedia page. But basically, that's what I told you right now. So the meaning of it is that you can change the variables during at runtime. So I can say x equals 1, and then the next step I could redefine x to be a string, things like this, right? And in addition to this, MATLAB variables can also change their type implicitly while you are doing calculations. So let me show you what this means. And it can become dangerous because, for example, let's say I say 1 plus a mirror. What do you think I get? No. Obviously, I mean, I would expect to get an error, but that's not the case, I think. You get a vector of numbers. What's happening here then? Exactly. What happens is that it's called operator overloading. So you have a number and you have a string. These are not the same type, but MATLAB has try to make this operator, the plus operator, smart enough to understand that when you have a string and you have a number, a double or integer, then combine the two, convert the string implicitly to a number, and then combine it with 1. So basically what's happening is that every character, you see we have 4 numbers, right? So each number corresponds to the ASCII number for that character. So A should be 97. So what happens is that, let's see what the ASCII for Amir is. You see? So if you want to get the ASCII code for a string, you can use double. I think you should be able to use other functions as well. So let's see. ABS. I'm not sure if this works, but yeah, so it works. Okay, so when you say convert Amir to double, it gives you a vector that corresponds to the ASCII numbers of these individual characters in Amir. So it has a length of 4, which is the length of this string, and then it adds 1 to each one of these numbers. So you get 98, 110, 106, 115. Okay. So this is called operator overloading, and it can also be dangerous because sometimes you don't really mean adding 1 to a string like this, but since MATLAB understands this as an operator overloading procedure, then it does this for you. So you have to be careful about this. You cannot do this thing, for example, in other languages. So I think that was it. Like, for example, crazy things can happen. So if you, by mistake, add quotation marks to 10, then you're not going to get 20. You get a vector that is the ASCII code of 1 and 0 and then plus 10, each one of them. All right, so if I say double 10, it's going to give me 49, 48. All right. Now, besides that, you can also convert the types. So, by the way, here's a better example. A nice one. So you add hello plus world. Both of them are strings, but MATLAB automatically converts it to a double vector when you add them together. Right. In Python, if you do this, it will concatenate the strings for you. It will not add them in the form of numbers. Right. So different languages have different standards and different syntax, different rules for their operations. Right. So keep that in mind. I'm not sure if we add more characters, what would happen? Gives an error? Yeah, so the dimensions must agree. I thought maybe it would pad the other one with zeros, or I don't know, with empty, with blanks, but that's not the case. Okay.
What does it mean by dimensions must agree?
The dimension means the length of the strings must agree. So both of them should be of the same length. So let's see how do you measure the length of a string? Oh, you could use size or length also, I think. Maybe. Let's try. Yeah, you can try length. Because I told you that string is a vector of characters, right? So, and to measure the length of a vector, you can always use length. Now, what would happen if you have a two-dimensional? I will answer your question in just a second. What will happen if you have a two-dimensional array and you want to measure its length? It's two-dimensional, so what would length give you? So number of columns, what other ideas? So length is going to give you the longest direction, the size of the array in the longest direction. Okay, so if I define 1, 2, 3, 4, 5, 6. So this is a two-dimensional array. It has 2 rows, 3 columns. Now if I say length, what is it going to give me? What was so the variable is answer. Don't work with answer, I told you. It's dangerous, but I do it all the time. So it's going to give you 3. Okay? So it has 2 dimensions, 3 columns, 2 rows. But when you say length of answer, it gives you 3 because it measures the length in the biggest direction, the longest direction, right? But if you say size, you see, that's a problem. So answer is gone now. I have to redefine this vector. Let's put it in a variable this time, test. Okay. Now, if I say size of test, that gives you the true size of this array in all the directions. The first one is the number of rows, the second one is the number of columns, right? Now, if I say size of Amir, it's going to give me two numbers, not one. It has one row, Amir, and it has 4 columns. And in each column, you have one character, right? What was the question? Yes.
Going back to what you said before, you said you can't change the variable like absent.
Yes.
Like, assign it, can't you set the variable as a symbol?
What was it?
Can't you set a variable to
Yes.
a symbol and then change it later? Can't you do symbol
Oh, what it's called. Yes. So yes. So you can do this. Yes. You mean in MATLAB or other languages?
No.
MATLAB. Yes, you can do this. Yes, of course. So basically, what you're saying is that the symbolic calculations, right? That's I think what you mean. So yes, you can do this, and I think there is some. One of the lectures is about it. I think probably future lectures. Yes. And Mathematica is the superhero of symbolic calculations. But you can also do it in MATLAB. So what was the other question? I'm sorry.
Oh, no, I was just going to point out here.
Okay. So that said, there are many functions that can convert the type of the variables for you explicitly. So what I showed you here is implicit type conversion. You have a character, and then it is implicitly, a bad example, it is implicitly converted to a vector of numbers, right? But you can also explicitly request this. You can say, for example, the name of the functions is very clear. So it says convert a cell array to a string, convert an integer to str or a string. The most useful are probably these int to str, num to str. These are the most useful ones that I use always myself. So str to num. But you can get a long list. So yeah, there's a long list of them here. You can click on this link and look at them. I don't want you to memorize them, but just know that they exist. I told you about these and about operator precedence in MATLAB. So I told you that if you are in doubt which operation is going to be executed first, always put it in a parenthesis, because then that operation is going to be done first, and then the other ones. You probably know this. How many of you know already about operator precedence? No? Nobody really? I should take it seriously then? Yes. The operator precedence? What it means is that if I say, the rules are almost universal. So if I say 1 plus 2 divided by 3, what's going to happen? What's the result of this? So 2 divided, it's a bad example. So let's divide 3 by 2. Okay. Now, what is the result of this? Is it 4 divided by 2, which is 2? Is it 2.5? Which one is it? 2.5, right? So already you know some of these rules. So that means division. What about star? 7. So you can get 1 plus 3, so you can get 8 or 7. Which one? 7. Okay. So division and multiplication have precedence over subtraction and addition. Right. So whenever you see these two, you first perform these operations and then go to the next one. Right. Now, what if I have 2 times 3 times 4? Doesn't make any difference, right? Whichever one you perform first. But MATLAB does it in a ordered way. So it always starts from, not MATLAB, any other language. They all start from the leftmost operation. They perform this one first, and then the result is 6, and then they perform the second one. Right? So keep this in mind. Always from left to right, and wherever you reach an operation that has precedence over the other ones that are on the left side, then those ones will be performed first. So if you have 1 plus 3 times 2, MATLAB starts from here. It says, okay, I have plus this number, but then there's a star. So this one will be calculated first, and then this one. Right? Now let's make it more complicated. Let's say I have 1 plus 3 to the power of 2 times 4. What is the result of this? Let me think about it myself. Okay, so I got an answer. What about you? 37? Okay, no other answer? Alright, so the result is 37. That's correct. That's because exponentiation has precedence over all other types of operations, including division, multiplication, addition, and subtraction. So MATLAB starts from here. It reaches 1 plus 3 to the power of 2, so that should be calculated first. And then there is a multiplication, so this one is calculated, and then finally this one. Right? Now, it could become more complicated. Let's say 1 plus 2 times 3 to the power of 2. Now, what is the result of this? 19, right. Again, this has precedence, so this one and then this one. So whenever you want to override this operation precedence, so you have to put it in a parenthesis. So let's say, for example, you want to take 3 to the power of 8 instead of 2. So you have to put this 2 times 4 in a parenthesis, right? So that's all of it. Now you know operator precedence, all the rules in MATLAB, and you're the programming guru now. So the last, oh, by the way, there is also operator precedence rules for the logical operations. So like greater than, less than, and or. To be honest, I don't memorize them myself. So whenever I'm in doubt, I just put a parenthesis around the operation just to make sure that the one that I want to be executed first, to be calculated first, are calculated first. That's it. So with MATLAB branching, you already know what a branch means. The normal flow of a program, you have a statement, and then you go to the next statement, to the next statement. With a branch, you reach a condition, and then that condition is either correct, in which case you perform a specific statement. If it's false, you do another thing, and then you get out of this if block. So this whole thing here is called a logical block, an if block, right? It's a way to control the flow of your program. That's why it's called flow control, right? So, but I think without any further explanations, let's just get to this example. Let's run this and see what you get. And then I have a few more exercises for you after this for class. Something like a quiz. So start working on this one. What does the input do for you? It asks you to, yes, so it asks you to, ask the user to enter something, right? Now, if you want to get a string as input automatically, you can just add, so see, if I'm gonna go to this page for a second. I apologize for that, but I want to show you something. So if I say a equals input, enter a number, and I say 123, Okay. Now, A is 123. What is the class of A? Double, right. But what if I say, what if I want a string? I can add string type here at the end. S stands for a string. And now whatever I input is considered to be a string. So now let's say class A character, right? Which is cool. And then, because sometimes you don't know what type of information you're getting on input from the user, so you just say get it all as a string, and then you can convert it to anything you want. So I can say str to num. What does this do? It converts the string to number, right? Okay, so going back to this page. So what this is asking you to do is to get a number from the user and then calculate its root and then make sure if so it's a square root function. You have to write a script for this, by the way. You cannot. I mean, you could probably write it in a command line, but it's not that easy. So I'll say create a script file for this one. Yes. Not a real number?
Yeah, it won't take the string or anything.
Oh, I think the message might be wrong, so let's see. It says, display, please enter a real number. Anywhere is negative. A real positive number would be the correct one. But what's the problem?
Trying to make that statement appear.
Yeah. Like what number can I put in to get the statement?
Yeah.
Oh, I see. To get the last one,
Yeah.
you could put a string as input.
Yeah, it gives you an error.
Okay. Let's see. So I have. So let's think about it. That's how you debug your code. So you run the code in your mind. I get an input, and it's a double, right? So obviously there's something wrong because, oh no, that's correct. So num to str. So that converts the number to string. So they say if a is larger than 0, then take the root. Fine. And then if it's not, else, please enter a real number. So what if you enter a string, a character?
Oh wait.
No, it shouldn't be like. Let's try it. Oh, so I think so. That's one of the things that I told you to be careful about, the implicit type conversion. So let's say what this. So you see, I have this condition here. It says a larger equal to 0, right? So let's try this. See if I'm here. And that's correct, yes. In MATLAB, that's going to be evaluated as true. Right, you see? So what was that?
Does it do the ASCII?
Yes. You see, it has 4 characters, so it converts everything to 4 numbers, and then all of them are bigger than 0. Oh no, so here's the thing. So when you say, so what's happening here is that, so that's why guys, you should be really careful about MATLAB implicit type conversion. You see, it has even caught me. So what's happening here is that it takes a mirror, it sees there is a logical operation here, so it converts a mirror to a vector of ASCII numbers. Right? So what is the ASCII number for a mirror? double mirror, then you get this numbers. And then compares this whole vector of numbers with 0, if they are bigger or equal to 0 or not, right? So if I say answer larger equals 0, it's going to give me all 1 because all the numbers are bigger than 1, right? So it gives you all 1. And then it all evaluates to 1, which is correct. Then it goes to this step. And it tries to take the square root of a string, a mirror, which doesn't make sense. So it doesn't go there. So you see, so I had probably, when I wrote this example, I had the mentality of some other programming language in mind. And these kinds of errors happen. So especially if you're coding, for example, in multiple language, you have to be real careful with MATLAB. That's why I said MATLAB is a little bit strange. Because it does things that are not normal in other languages. So, but anyway, if you want to get to the last one, you have to make sure first. But what we could do is to, let me put this in a script and then revise it. How can we make sure that we have a string? We do not have a string, a number. No, we want to make sure if we have a string in the beginning. So I could say, I could add another if block. I could say if is real A. You don't need this parentheses, these are unnecessary. And then for the rest of them, always use tab and then end, okay? But then it's never going to get here to this last one, because if it's real, it's going to get to this. The real number is either bigger than 0 or smaller than 0, then that's it. Oh, by the way, here's the thing. How about complex numbers? What if I copy this code and run it on the command line? But it can take the square root, so I think there shouldn't be any problem. So let's see. If I add 1 plus I told you what I is. I is the square root of -1, which doesn't have any meaning, right? So you see, there's no problem. It can calculate the square root of 1 plus I. So if I say square t 1 plus I, gives me this. So 1 plus I is larger equals 0, and the answer is yes. Okay, yes. Okay, is real. Make sure if your number is a real number, so that it avoids.
Shouldn't it avoid the numbers?
Yes, it should. So let's see. If you put mirror here, so it even converts a mirror to a real number. So let's see. What else can we imagine? Is double maybe? Maybe this would work
But that's just
on the find function. What was that?
check your input. How do you make the input actually work in the if block though? Because if you're just checking it, then it's just going to output that that's not.
Can you say it loud again so everybody hears?
So, well, I'm just if you're just using that if block
Okay.
to check if it's
Real? No. So I wanted to make further changes to this if block. So I wanted to put something here that checks if the number is real number,
okay.
real positive number, and if it's not, oh no, not positive, just real number. And if it's not, this else comes here. So you can have nested if block now. And then I can take this end from this place here and put it here. You see, so I have nested if block now. First I check if the number is real. And if it's real, then in the next step, I make sure if it's positive. If it's positive, then I calculate the root. And if it's not, then I get out. But now the problem is, how can we get a function that tells us if that's a string or not? I don't remember anything else. Let's try this. Israel. Oh, it's gonna give us Israel. Ne? I know this because this happened a lot to me. So Israel. Let's go to the end and see what we have. What are is finite, is inf, is non, is numeric. Okay, that's the one that we want, I think. Yes. So let's try is numeric here. Let's see. Is numeric, Amir. Obviously it's going to give us 0. Excellent. So that's what we need. So with this, now if I save this here, what happened? Test desktop. Okay, now if I press F5 to run this code, change, it's going to ask me a number, and if I say Amir, it's going to give me this message, right? Now, in your exercise, in your homework, I've asked you to write a similar if block in your code for the Fibonacci numbers. So what you need to do is to make your code robust against, basically you have to make your code foolproof. So if somebody enters a string to your, inputs a string to your function, then your function should be smart enough to understand that it's a string and then warn the user that it's a string, and then it has to loop again, go back without for loop. It has to call the function, it has to call itself to request for another number from the user. Yes, there was a question there. A question? Yes.
Can we just make a bunch of else ifs still?
Yes, why not? Well, you mean?
Because you put if and numeric A, it's just a simple way of just putting a bunch of else ifs.
Exactly, yes. I mean, you could, basically, you can write this nested if block in so many different ways. So there is no single way of writing these if blocks. So you could combine these. You could say if is numeric and short circuit and a is larger than 0, then take the square root. Else if is numeric and a less than 0, then do this. You see what I did? So then else display this message. That's going to be the exact same thing as the previous one. You see what happened? So I removed the nested if block and I combined the conditions that I had for the two if blocks with each other, which is, I think, a better way of writing it. Yes.
Can you try running it with just the number 4? Because I think there's
4?
an issue with numbers string.
Let's try this. Enter a number 4, gives the square root 2. I have to make the message more meaningful. The square root is not equal to 2. The square root of 4 is equal to 2. So the way to do this is to add num to str4 okay, so now it should work. Now it should give me a square root of 4 equals. Right, if I type 4, square root of 4 equals 2. Oh, good point. Yes, so that should be A. Yes, that works now. Yes. So if I say 4, and then if I say 5, all right, it works. Okay, so now I have a couple of exercises here. Where is it? Okay, write a MATLAB script that takes two predefined matrices, A and B, as input and determines whether they have equal size. How do you compare the sizes of two MATLAB matrices? This one is a rather difficult question, but think about it, and I'm gonna.
Is there like a length function?
Yes, size.
Size?
Yes, size is gonna give you the size of a matrix, right? So if they have the correct size. Let me see if the question is informative enough. It says two predefined matrices. So let's define them here for ourselves. So let's define A to be 1, 2, 3, 4, 5, 6. Okay. And B, the inverse of it. Or no, let's say make it equal to 7, 8, 9, 10, 11, 12. So we've got two matrices now. And the question is to compare these two matrices, the sizes of these two matrices, and then combine them. Concatenate them horizontally or vertically needed. Okay, I'm going to give you some hints. For that, you can use
So we're just supposed to.
So let's suppose you have defined these two matrices A and B, and then you write an if block that takes these two matrices and compares them with each other, if their sizes are equal or not. Okay, you cannot use, so let's say size A equals size B. You get 1, 1. Okay, so that works. Yeah. But you could also take it, you could make it more complex. I don't want you to do this. Just wanted to make sure if the two are equal or not. But you could write it in a more complicated way and say, compare the row-wise length of these matrices. If they are equal in the row-wise, then concatenate the two matrices in the row direction. If they are, like, for example, if both of them have two rows, then they have equal rows. So concatenate them in the direction of rows. You see? So you have the first matrix here, the second matrix, you can attach them to each other, right? If they have equal number of columns, then you could put them on top of each other. One goes to the top of, yes.
What does doc is equal mean?
Doc? No, doc, that means documentation for is equal. I was wondering if you could use is equal, but is equal gives you something else. If I say is equal A, B, that's not going to help us. I think it will give you 0. You know why? Because it compares both the size as well as the content, the elements. So if the elements are not equal to each other, so if I say is equal A, it's going to give me 1 because A is equal to A completely. Yes?
So are those two ones for each dimension? Like compare each dimension and saying it's the same?
Right.
So how would you deal with that if you want to make it if they are, you just say if size A equals size B?
Yes, that's one solution. But then you could also put the size of the variable in another variable, and then call its elements. So I could say size of A equals size A. Now, if I say size A 1, it's going to give me 2. You see? And then I can compare it with size B. I could say size of B equals size of B. Now I can say size A, the first element, the rows. Are the rows equal to the number of rows in B? And the answer is yes. Are the rows equal to the number of columns in B? The answer is no, so you get 0. Right. Yes.
I guess what I'm saying is like I'm kind of confused how the two choose work, because like if you wanted to do an if statement,
Yeah.
like if like size
Oh, I see.
that means something, how
Yeah.
would it know like let's say one of the dimensions were the same, but the other one was?
We can test it
What would happen?
for sure. Yes, we can test it. So let's define a C variable. Let's have equal number of columns, 1, 2, 3, but 1 row. Now, if I say size of A equals size of B, you get both 1s, right? Then let's try with C. You get 0 and 1. Okay. Then the question is, how do these two compare with each other, right? So we could say this: if answer, then display or, else display and. You see what I'm doing here? I'll tell you in a second. And. Okay, it prints and. What does it mean? It means if you have vector of zeros and 1, it assumes that there is and operator between those values, right? So if 1 is 0, the other one is 1. So what happens? I said put this size of A equals size of C in a variable. Let's put it in test. What happened? Okay, so now test has these two values. So size of A in the number of columns is equal to the size of C in columns. But the rows, the number of rows is different. A has 2 rows, C has 1 row. Now if I write an if block like this here, instead of answer, I have to change this to something else. I have to change it to test. Now, the value of test is 0 and 1. Okay. Now, if I use this test vector in if statement, what do I get? So I have this if statement 0, 1. I have a vector of 0 and 1, and then my question is, what happens if I run this if block? Will it execute the content of this if block, or will it just skip it? What does this evaluate to? True. The can test is actually much easier. So I could say logical test. Oh, it gives us a vector again. But anyway, so if you put this vector in an if block, it assumes that there is an and operator between them.
So it assumes that there is an AND operator.
It says 0 and 1.
Yes, it says 0 and 1, so it doesn't execute this part for you.
So size A, that wouldn't work.
No, it would work actually, because what I asked you was to compare if the two matrices have equal size, and if they have equal size, concatenate them with each other, right? So if the two matrices do not have the same size, it's going to evaluate to 0, right? Let's say even if the number of rows is different, then it's going to evaluate to 0, so it doesn't concatenate, right? So all you need to do is to just say if size of A equals size of B, that's it. But if you say, what was that?
The size of A and size of B would be equal, so it's 1 and 1, right?
Yes, 1 and 1.
But that's 0. So,
Yeah. Oh no, but yes. So in this case, so that would give. That's what I was telling you. So if you have.
I'm working
We'll talk about this more next time, guys. So
But,
see you next time.
let's see, what are our next hours? I can meet. I've added you as a collaborator, You know, it's weird. I can't access my Halo 1 at all. It doesn't show it up. It shows as a link. It just shows text. So I click on it, just do it.
I hadn't thought about it myself.
Wait. What was Yes. I'm sure I submitted that, but I'll double check. Thank you, Mike.
Yeah, if you want to be really careful, you have to find the variable size, and then you take the elements of size and compare them to each other. So for the column concatenation, all you need to do is to say, you have your extension, say C equals A, length gives you the longest direction, length of the longest direction. You have to get it from side.
So on the homework, the first question is
Yes.
the normal distribution.
Yes.
I made this last night. I was wondering if like this is a